I want to introduce a few dictionary methods to you. First of all, let's remember what methods are, right? So remember that methods are like functions, or they are functions, but they're specific to a data type. So the append is specific to list, and lower is specific to strings, etc. Here's one method that's specific to dictionaries, the get method. So with this method, we can take a key, or in this case, the variable name of the key, and we feed it into get as a parameter. And when we run that code, it will return the associated value to that key. Now, if the key doesn't exist, it returns none. This is different than if we use the square bracket notation to access a key, because if you use a square bracket notation with the key in the square brackets, if the key in key value pair is not in the dictionary, it's going to return an error called a key error. So instead, this will return none. Another thing about the get method that you should know, which is very useful, is it has an optional second parameter. This parameter will return if none is what it would normally return. Okay, so in other words, it's going to look for the key, and if it doesn't find it, instead of returning none, it's going to return this value. And we'll actually add that value to the dictionary. So it's if it looks and sees that this key is not in the dictionary, it will add this key with the associated value -1 to the dictionary, and then it will return -1 as the value for the key. So that's a very useful method to use when you're not sure if there's a key, or if you want to make sure that a certain key value pair is in your dictionary. Another useful method for dictionaries is the values method. This returns what you could call a view of all the values in the dictionary. And you can then cast that to a list and get a list of all the values. Correspondingly, there's the keys method, which does the same thing. It will return all the keys, which you can then cast to a list, so then you can have a list of the keys and a list of the values to do what you want with. The nice thing about these two methods is if you use them together in a program, even though dictionary is not ordered, it will return the keys and the values in the same order. So then the two lists that you have from these two methods will match. The value at index 0 in the value list will match to the key at index 0 in the keys list. When to use dictionary? There's a lot of reasons to use dictionaries. There's sometimes when it's better to use list. Let's talk about times when dictionaries are very useful. So dictionaries are the best data structure to use if you have data whose order doesn't matter. If the order of your data does matter, then a list or tuple would be better. If you have a set of unique keys, then a dictionary can be very useful. If you don't have an association between two things where one of them is always unique, you might want to use a two-dimensional list instead, for example. So for example, a good time to use a dictionary is if you have, well, using the metaphor dictionary where it kind of comes from, is if the key is a word and the value is the definition, or a translation of that word into another language. Another great time to use a dictionary is if you have postal abbreviations and the full state name. And the key could be the postal abbreviation CO, and the value then would be Colorado. And in that case, you could reverse it as well, because they're both unique. Another time would be if you have names of players that are unique names, and the values could be their game scores, which you could then use that dictionary to display the names and their scores on the scoreboard. Another time dictionaries are very useful is when you need to find things easily and quickly. And we talk about in another video that how dictionaries are very, very good. They're better than lists for finding things easily and quickly because of the hash function that's used with dictionaries. And also similar to that, A dictionary is great if you know that you have values that are going to be added and removed or updated a lot of times, because a dictionary can also do this very easily and very fast, faster than a list. Let's look at an example of when you could use a list or a dictionary, but one is definitely better than the other. So we could model a dictionary, an actual dictionary, where we have words like aardvark and zwieback, and then we have their definition. We could model that as a list of lists, a two-dimensional list where each element in our list is another list with two items, the word and its definition. If we want to find, like search for a word and find its definition in this two-dimensional list, this is how we would need to do this. We can create a function called findWord with two arguments, word and then the list that has our dictionary. We would then need to iterate over the items in the list. So iterate over each list that has the word and the definition in it. And as we iterate over it, check the first item in the list, in each of those lists, to see whether or not it matches the word we're looking for. If it is, then we can return the definition that's in that list. Now, what if it's not in the dictionary, or sorry, in this list that we're using to model a dictionary, an actual dictionary? The only way we're going to know this is by going over each and every word in our dictionary and looking to see if it matches. We won't know if the word is not in our list until we get to the last item. So if there's 1,000 words, or like I think the English dictionary could have potentially 2 million words, we're going to have to go through all 2 million words to find out that our word is not in the dictionary. So this statement, this if state, will never evaluate to true, meaning that this return statement will never run. So then we can, after we've done that iteration through every element, we can get to this return statement. So remember that when you have a return statement, if it does run, it immediately exits the function. So if this return statement is not running and it goes through every item, we get to the end of the loop, the next line would be this return. So we could return it's not found. And then we could run this function. It would go through until it found, I mean, this would probably be very near the very end of our list. This could actually take several seconds to get this definition back. We could also model this as a dictionary, in which case we would have our word as a key and the definition as its value. And to search through to find out whether that word is in our dictionary, our Python dictionary that is modeling a real dictionary, this is all we need. We just need one line where we use a square bracket notation to search for the key and see if it's in the dictionary, and that will return our value, which is our definition. And this will happen almost instantaneously, even if we have 2 million words in our dictionary. So it's much faster, it's much better than using a list in this case. Note, we could add some more code here, because if we use a square bracket notation and the word happens not to be in our dictionary, then it's going to return a key error. So instead we could add some, and you can think about how to add some code here, and instead of using the square bracket notation, use the get function, which would return none if it's not in there, and maybe we could add the word. So in this case, with a real dictionary, it's great to use a Python dictionary, not because we want to quickly add or update. Words do get added to a language, but not that fast, although we could very easily do that with a dictionary. The main advantage here is not only is it easier to write the code to find the word that we're looking for, but it's going to be finding that word and returning its definition much, much faster.